Hi there, this is Nilson Lima. And about the possibility to add landscape modulation for tile landscapes. Just to cover first the basics about this, you see that in this section, Ocean, for the BP Ocean blueprint, we have here the height map texture that was used to build the landscape when you just import a new one. Okay, and basically this is the same textures. Usually people that use Word Machine, Gaia, or other terrain sculpting tools, they use the R16 or raw type of files, but you can also use a PNG. So the kind of texture that works here today for landscape modulation has to be a PNG. You see that when I place my mouse cursor over the texture, it shows that filter is using a trilinear. The compression settings is a vector displacement map. sRGB is set to true, and the format is BHG8R8A8. It's a 8-bit map. Okay. When you enter here, I double click the texture so you can see how the settings has to be. You must not use MIP maps. We want the raw texture to be used. sRGB is set to true. This means that once you imported those height maps, they have to be set like this. I am not sure why this size is a little bit weird. This kind of size. Okay. Anyway, just for us to check this, when I click here on the landscape, you can see that it is scaled down to 80. I'm not sure why. When I click here on the landscape manage, if I go to change component sizes, you see the overall resolution, it's a bit weird. The usual texture size to not having tiling issues when you go into a tiled map should be like 4033. This will be the correct size. So you have to go after a size specification that will not have tiling issues for your world composite landscape. Getting back to the BP Ocean, and so what is interesting to have this to work properly? Let's suppose our landscape is 4 tiles. So it has to they will be like enumerated like x0 y0 x0 y1 x1 y0 x1 y1. So you have your 4 textures. So you want to have that name convention kept, because it will be that naming convention that will help you to figure out the correct placement to build, because as you can see you're here at the top. Okay, this select here is our landscape. So when we import those landscapes, we'll have a double, I guess I just going to crash. Let's wait this a little bit. I just try to duplicate this. Let's see if it worked or not. Yes, it worked. So we'll have, so this will be x 0 y 0, and then x 0 y 1, whatever. It's 0 1 0 0 and 0 1. 1 1 0 and 1 1. This is how the tiles will be placed. So you need to know the sequence, because you have in the C++ code to know when you are going to reach the boundary, and it will be the next tile, the next file you have to take into account. Okay, so this is one thing important. Of course, one thing is saying let's get to the Visual Studio for this one. And the code who deals with this logic let me remember this. It has to be with, I think it's the buoyancy. It's relevant to the buoyancy. What is the Ocean Manager? Yes, it's the Ocean Manager. Okay, so you have this. Let me close the other ones. Yeah. Of course, the get wave height is probably the one being affected by the landscape modulation. So here in the Ocean Manager CPP, you have get wave height, and you can see I check if this landscape modulation is enabled or not, because in the blueprint we do have a boolean here saying it is enabled or not, and so all these following parameters are used there. We have a reference for the landscape and the height map. This is because we need the Z. Okay. So you see we got here landscape. We are checking if it is valid, because if I have this guy here blank like this, it doesn't matter. You see that once I have cleaned out the landscape, the waves just change it. They are not being modulated anymore. And so this is a consequence of that setting being cleaned out. So I place landscape modulation, you see that we have again bumped here. Another thing is, if I have this texture here clean out, we are in the same spot. Okay, place it, we are get it modulated again. And if I turn this off, if you turn it off, it seems we are not having any change here. I can feel a click there. Let's see why in the code this is not being passed away. So if I click here to open the blueprint, and let's find out landscape modulation. Yeah, it's not here. So it is because it is coming from Ocean Manager. It is exactly the guy we are setting here. So B enable landscape modulation. Let's go to the declaration. See, it is a U property. So for this name, it will remove the B, enable landscape modulation. It is exactly the name we got there. So click on the class defaults, and we get our landscape modulation here. Then you have start height and max height. Start height, max height here. That's how you get it. And so back here, it's still not clear, but then we are getting the actor location, getting the coordinates for for the landscape. And getting the coordinates for the location. Getting the scale in 3D. It is weird, but the point here is that we are having this math here being done, taking into account that the landscape is just one tile. Because those type of measurements are possible because as one tile only, this guy here, it is fed as an attribute for BP Ocean. We have all this detail, but when we are talking about a tiled component, you don't have that information. You can have the scale, but I don't think we have the other data. So maybe it is necessary to enter with all this data for you, so you can have something valid. And you see that just here in the end, we are calculating this block here is just to have this value. If this is not true, this value will be 1. It is set here at the beginning. You see, it needs the root component z, because here in the map, if you change the z here, you can change the height for your ocean. So let me save this value here. So if I place here with 0, now we are underwater. So that's why it takes the z, and has to be for the root component. It means you are blueprint. There is a function here to load the texture, and this function here is storing the world data into a buffer. We are reading the data here, and with the width and height for it you are getting from the texture. Since we don't have MIPS, so this is why we're using MIP 0 here. Otherwise, if you are using MIPS, you would have MIPS 1, so you have the data for the MIPS 1. We don't want, we want the precise amount of height. We got the data here. And we are storing in this place and adding to height map pixels. Height map pixels must be defined somewhere here. It's an array of float 16 color So basically we are having an array. Again, this array is just for one single map. So you have to be an array of arrays for this to work properly. We still need to go to this function here, go to definition, here getting the height, read the pixels, but then we have another one here, wave height value. We're getting a float. And here I'm getting a vector. So it seems we have several functions used in several places. So every place we have the calculus for landscape modulation, we need to make the changes necessary to accommodate multiple maps. So remember that we are storing the height map pixels into this array. So to work with multiple maps, we need an array of these arrays. So in my example, I have placed it on 4 tile. So this be an array of 4 of these guys here. Let's see all references for this. So doing this, you know where are the places I'm using that information. Okay. So this is a quick way to know where you need to go and change the formulas a little bit. It's not that much places. The important on the algorithm to do these readings is to understand when you get the location you need the information. It will be the index for the 2 dimensions array you are going to have. So you need to calculate if it's given a coordinate you are evaluating. Remember, you get and all the functions we got here, we'll know the locations that are used here for for the math, and given this location, you need to figure like get height map pixel, this place here, and where it will be, it will be the index for the array. It's 0, 1, 2, or 4. So it has to be coded in a way that you can find those index first, pass this index to the function. So you have this index passed here, so it be determinant first, and then this will make the search into here. Here is the vector being looked at. So you have another index here because it's now a two-dimensional. So we need to know if it is 0, 1, 2, or 3 for that example. Okay. So the math should take into account this for this to work. Seriously, it's a little bit of trouble, but you see that's just a few places, because since I have listed all the references here, and it is given just few ones here, it's not many places that you have to look for these changes. I just need to know that you can't mess with the index for the array. So it need to be an array of this array, and here at the blueprint, you give to provide an array here of textures. So the problem is, was the textures given the correct order? You can't know for sure. And then for this, you have to maybe use the names and wrote somewhere that you have to keep the names, that X and Y that I have talked before, the X0, Y0, X1, Y0, and X0, Y0, and X0, Y1 and 1. Okay, this is the naming convention that when you are going to load, so the size of this the array here will determine how will be the the size of the first dimension array here. And when you're going to make the load, when you do the load here, when you are loading the textures, the interest in here will be to provide the index already for the array. So let's see where we are having this being called. Oh no, this is a bad place. So it is loaded when we have a beginning play. So this has to be changed as well. or you change this, because right now we are just having one texture here. You can as much have, because having just one texture here is not enough. So you have to have the index where you are going to store here. Otherwise, it is that is no use for this. Yeah. The issue is where you decide it is the index you're going to give. You know that the index for that example goes from 0 to 3. So 0, 1, 2, 3. And this will be totally fine. If you are just loading the texture at the begin play, it's one thing. It should, I'm not sure if in the constructor we are doing this. Let's see. Construction script. Let's see if I can find the references for height map texture. It's not good. Should be find. Choose the name again. Height map. This portion here and the blueprint have to be changed as well. You see that we are using that texture, getting the coordinates and placing them in the parameter collection. This is going to be another issue. This is basically more difficult to change than the C++ code, because mainly because the MPC you can't change at runtime at all. Oh boy, this point here is the worst complicating scenario, unless you make the changes in the NPC collection that is quite big, this one. So you can have already stored yeah, this is the This is being passed to the material as well. You have to check in the material what the hell it is doing with that texture. I'm failing to find where that texture is used. Maybe it's not being used. It's a parameter value. Let's try to find so if it's the ultra, is this one. Because it might be collapsed, so I have to take a serious look up close and see if this is not the case. I'm failing to find it. Maybe it has no use at all. Maybe not in this material. Those are normals. and these are stuff not being used, so maybe you can find it here, so it can disconsider the whole thing. Let's see if this unused code. Seems so. Not here. Not here. If it was part once, a long time, it is not anymore. So best way to figure this out is like come in here and we will break here and we do this. I see no difference at all. Yeah. So that is probably an unnecessary code. Yeah. From what I can see, this is the only places that the changes have to and I say that the formulas are used for all the, because we have eight waves that are in use. They call this clusters. See, wave clusters. They are 8. So you can see that in the material and you can see that in the code here as well. You see that is some pre-data here. So basically, if something is not okay, just click to find the references and you know all the places you have to do the changes. I think that's it. We saw where here in the blueprint we have to changes, where not. We said that this place here doesn't matter. I will discard this, don't have to even save this. But I think this is enough information to understand the places. I was worried at the principle for the data stored on the MC. Now I am not sure if that is any other thing. And if that's so, all you have to do is go after those data being stored here and figure. You see that it already have, in case of the wave sets, the 8 ones, they have prepared all the. So maybe if you needed to support some data from the height map here, you can like, so the terrain you're going to use will be composite in the maximum 8 tiles, 10 tiles. You have to make your decision, because the more the tiles, more complex will be the changes here, if it is really necessary. I don't think it is, but I may have missing something. So that is quite some changes here for the C++ code, but it mostly is just trying to keep the math using the correct indexes for the height map. Like this check here, this check you'll be completely different when you're talking about a different number of instances, because here it doesn't have to care because you have just one. So maybe this check here needed to change. Maybe you have a loop here when you pass the check for each vector position. So in our example, for 0 to 3, or if you decide that your terrain will be maximum like 10 pieces, or 0 to 9, whatever. This is probably the amount of changes you have to do. I guess keeping the settings as I mentioned is one of the primary goals. Making sure the PNG of it imported height map is correct. Where is it stored? And ship as an examples. So my primary concern would be making sure the data for and the size for the textures. Having any doubt, you can right click here and UE4 landscape sizes. I guess it is this one. No, it's the first. So down there you see these are the sizes that you want to have for each tile, so you do have a perfect and seamless transition between them. Let's see, when you have this repeated, you can see that you have just the sections component a different number. This is mostly the sizes you have to have. I hope this helped you guys to do the changes in the code. See you guys soon. Bye bye.